All of you mute your mic. Let us start today's session. Today we are going to start revision number 2 of chapter number 10 circles. जहाँ पे रुके थे वहाँ से continue कर रहा हूँ मैं. So exercise 10.2, 10.4. If two equal chords of a circle intersect within the circle, prove that the segment of one chord are equal to the corresponding segment of other chord. See this figure. AB and CD are two equal chords and they are intersecting at point E within the circle, circle के अंदर में. And the line, the segment of one chord are equal to the corresponding chord. So इसमें हम लोग एक construction करेंगे. We'll join O, we'll draw perpendicular from O to AB and to CD. So OM, draw OM perpendicular to AB and ON perpendicular to AC. Right, so पहले OM perpendicular draw कर लिए, then ON draw कर लिए. Right, now what we have to prove, AE is equals to CE, DE is equals to BE we have to prove. Okay, तो सबसे पहले हम लोग क्या करेंगे, इसको join कर लेंगे OE and we will prove these two triangles congruent. Okay, now we are going to take that two triangles, OME, ONE. See this yellow and green triangle. Right, now these two are equal. Why? OM is equals to ON.
Each 90 degree.
No. Side OM is equals to ON. See, chords are equal. Equal chords are equidistant from the center. So OM is equals to ON. And OE is equal because common side. And these two angles are equal, each 90 degree. Right? So these two triangles are congruent by which criteria? Which rule?
RHS criteria.
Right, RHS congruence rule. Now, if these two triangles are equal congruent, so ME is equals to NE by CPCT. Okay. Now we know that perpendicular drawn from center to chord bisects the chord. Right? O is the center. OM is perpendicular to AB. So AM is equals to half of AB. Why? Because perpendicular drawn from center to chord bisects the chord. Perpendicular drawn from center to chord bisects the chord, or simply perpendicular from the center bisects the chord you can write. Right? Now similarly, NC is equals to half of CD. But AB is equals to CD. So half of AB will be equals to half of CD. So AM is equals to NC. Up to this step, it is any doubt here?
No, sir.
Okay. Now what we will do, we will add ME is equals to NE to this two. Okay. Similarly, MB is equals to ND because these two are equal. Chord bisects, perpendicular bisects the chord. So now we will add AM is equals to NC and ME is equals to NE. So we'll get this one. So if you add these two, what you will get?
AE.
Right. If you add these two, what you will get?
CE.
C. Very good. So AE is equals to CE. First part is over. Now for second part, what we will do? We will take this two. AB is equals to CD, it is given, and we have proved just AE is equals to CE. Now we'll subtract these two. If we subtract these two, we'll get AB minus AE is equals to CD minus CE. What you will get if you subtract these two? BE, right. What you will get if you subtract these two?
DE.
DE. Very good. So we'll get BE is equals to DE. So यही proof करना था. Any doubt?
No, sir.
Okay,
No, sir.
next question. If two chords of a circle intersect within the circle, prove that the line joining the point of intersection to the center makes equal angles with the chord. So everything will be same जो पिछले क्वेश्चन में किए थे. Every starting OM perpendicular to AB draw किए, ON perpendicular to CD draw किए and join OE. Right? So these are same. and here also we are going to prove these two triangles congruent, right? So how we have to prove these two triangles congruent? First of all, OM is equals to ON. Why? OM is equals to ON.
Well, chords are equidistant from the center.
Very good. Equal chords are equidistant from the center. And OE is common. And why these two angles are equal?
Each 90 degrees.
Each 90 degrees. So therefore, these two triangles are congruent by which congruence rule?
RHS congruent.
Right, RHS congruence rule. So हम लोग को प्रूफ क्या करना था? ये दोनों एंगल्स इक्वल है. See, the line joining the point of intersection is E. To the center, that is O, means OE makes equal angle with the chord. That means ये दोनों angles equal proof करना है. So now here we can conclude by CPCT. Any doubt?
No, sir.
Okay, one more question. If a line intersects two concentric circles I already told, two circles or two or more circles with same center are called concentric circle. With center O, A, B, C, D, prove that AB is equals to CD. So AB is equals to CD we have to prove. So what we will do? We will draw one perpendicular from O to this chord. Okay. So this is perpendicular. And we know that perpendicular from the center to chord bisects the chord. So we'll take this point is L. So BL is equals to CL for this circle and AL is equals to DL for the outer circle. Okay. So whether this is clear?
Yes, sir.
Now we have to subtract these two equations. So AL minus BL, what you will get? AL minus BL. AB, right. And DL minus CL? CD, right. So this is the proof. Any doubt?
No, sir.
No, sir.
Okay. Now this is very good question and very important also. And this question can be used for case study based question also. Three girls, Reshma, Salma and Mandeep are playing a game by standing on a circle of radius 5 meter drawn in a park. Reshma throws a ball to Salma, Salma to Mandeep, Mandeep to Reshma. If the distance between Reshma and Salma and between Salma and Mandeep is 6 meter each, what is the distance between Reshma and Mandeep? So this we have to find. So this is the diagram. R is the position of Reshma, S is the position of Salma, M is the position of Mandeep. And the distance between R, S, that is Reshma and Salma, and Mandeep and Salma, it is given 6 meter. So whether diagram is clear?
Yes, sir.
And we need to find the distance between Reshma and Sandeep, that is RM we have to find. So we'll start with the first right of work. Let R, S, M be the position of Reshma, Salma and Mandeep respectively. Now we will draw one perpendicular from O to RS and O to SM. See, सबसे पहले OA perpendicular draw किए, फिर OB. Right? Now we know that perpendicular drawn from center to chord bisects the chord. So what is AR?
3 meter.
3 meter. Right.
3 centimeter.
Not centimeter, meter. 3 meter. Okay, so AR is equals to AS is equals to half into 6, that is 3 meter. Why? Because perpendicular from the center to chord bisects the chord. Right. Now, similarly, these two are also 3 meter. BM is equals to BS also 3 meter. अब हम लोग क्या करेंगे? इसका एरिया निकालेंगे. ध्यान से देखो. We'll find the area of ORS. How will you find this area?
Using Pythagoras theorem.
Area. Half into base into height. Right. So base है हम लोग के पास RS, but height it is not there. So we will find height first by using Pythagoras theorem. Right. So this is 3 meter, and what is OR? OM OS, these are the radii. So they are equals to 5 meter. Now we got ORS is equals to 5 meter. Take this triangle. How will you find OA? By using Pythagoras theorem, right? So by using Pythagoras theorem, we'll get OR square is equals to AR square plus OA square. Now we need to find OA square. So इसको यहाँ पे shift कर लो, right? So minus AR square हो जाएगा. Otherwise you can substitute and shift. So we'll substitute. So this will become 9 and this will become 25. If you shift 9 to this side, 25 minus 9, what you will get?
16.
16. Square root of 16?
4.
4. So OA we will get 4. Clear?
Yes, sir.
Right.
Yes, sir.
Okay. Now one very important property is there. ध्यान से सुनो. This is a line segment, and if we draw the perpendicular bisector of this line segment में कहीं पर भी point लोगे, if you take any point on the line segment perpendicular bisector, so that will be equidistance from the end points of the line segment. You take any point, कहीं पर भी point लो, this will be equidistance. ये तो सब equal रहेगा. And converse is also true. अगर उस line में कोई भी point equidistance है, that line is perpendicular bisector. So यहाँ पे see OR is equals to OM, and so therefore OS we can write is a perpendicular bisector of RM. Whether this is clear?
Yes, sir.
Okay, so for that we have to write, we know that the point lies on the perpendicular bisector of the line segment is equidistant from the end points of the line segment. So here OR is equals to OM implies OS is the perpendicular bisector of RM. इसका मतलब ये वाला 90 डिग्री है. क्लियर?
Yes, sir.
ओके. नाउ अब हम लोग ORS ट्राइंगल को का एरिया दो तरीके से निकाल सकते हैं. We can take by using base as RS, or we can find the area of the same triangle by taking OS as the base. Okay. So if you take the base RS, what is the area of triangle ORS? Height will be OA. Formula क्या है? Half into base into height. So half into RS into OA. Clear? Now if you take base OS, so RC will be the perpendicular height. So half into OS into RC. Whether this is clear?
Yes, sir.
Right. So in triangle RSM, angle RCS is equals to 90 degree. So RC is equals to CM because OS is the perpendicular bisector of RM. Now area of triangle ORS is half into OA into RS. This can be written in another way that I already told, half into RC into OS. Now this half we can cancel, and OS is 5 and this is 24. ठीक है? So RC into 5 is equals to 24. So 24 upon 5 will be RC. That is 4.8. So what is RM?
2 into RC.
Very good. 2 into RC, that is equals to 9.6 meter. So we got the distance between Reshma and Mandeep as 9.6 meter. Any doubt in this question?
No, sir.
Okay. Now the last question of that exercise. A circular park of radius 20 meter is situated in a colony. 3 boys, Ankur, Said and David, are sitting at equal distance on its boundary, each having a toy telephone in his hands to talk each other. Find the length of the string of each phone. So this is the diagram. Let A, B, C are the position of 3 friends, Ankur, Said and David, and their distance are equal. That means AB is equals to BC is equals to AC. So which type of triangle it is? ABC.
Equilateral.
Yes, equilateral triangle, because all three sides are equal, right? And wait, हाँ, यहाँ तक आ गए हम लोग. Now AD, BE and CF are the medians. Now इक्विलैटरल ट्रायंगल का एक बहुत अच्छा इंपॉर्टेंट प्रॉपर्टी क्या है कि जो ऑल्टीट्यूड है और मीडियन है दोनों सेम रहता है. And centroid, ortho, center are also same, right? So AD, BE or CF are the medians of triangle ABC, and let G be the centroid, its centroid. और G जो है वो सर्कम सर्किल भी है, सेंट्रॉइड भी है, ऑर्थो सेंटर भी है और इन सेंटर भी है. दिस इज द प्रॉपर्टी ऑफ equilateral triangle. Now since in equilateral triangle the centroid coincides with its circumference, so we have GA is equals to GB is equals to GC is equals to 20 meter radius. Already it is given 20 meter, right? Next part, or one of the most important property of centroid of a triangle, that it divides median in the ratio 2:1. So AG upon GD will be the ratio is 2:1. Okay, and this we got this is already given 20 centimeter. So 20 upon GD is equals to 2/1. So GD we will get 10 meter from this. ठीक है, ये 10 मिल गया और ये 20 है. सो टोटल AD कितना मिल जाएगा? 30 मिल जाएगा ना?
Yes, sir.
ओके फाइन. नाउ बट हम लोग अभी क्या करेंगे, ये वाला ट्राइंगल लेंगे, दिस ट्राइंगल BDG triangle will take, right? And this I already told, this is altitude median दोनों सेम होता है. And we got this as 10 and this is already given 20. So how will you find BD?
Pythagoras theorem.
Pythagoras theorem. So BG square is equals to BD square plus GD square, that is by Pythagoras theorem. So 20 square is equals to BD square plus 10 square. This is 400 and this is 100. So we'll subtract. If you shift this to this side, it will become minus. Okay, so 300 आ रहा है. What is the square root of 300? 100 का तो 10 होता है, 3 का स्क्वायर रूट नहीं होता है. So 10√3 meter BD. So BD मिल गया. Now what we have to find actually here? BC. So how will you find BC then? Perpendicular drawn from center to chord bisects the chord. So BC will be 2 times of BD, right? So 20√3 meter. Hence the length of each telephone string is 20√3 meter. Any doubt here?
No, sir.
Okay. Now we'll move towards angle subtended by an arc of a circle. So if two chords of a circle are equal, then their corresponding arcs are congruent. Conversely, if two arcs are congruent, then their corresponding chords are equal. See, if AB is equals to CD, so इनका जो arc है, this one, this arc is, the length of this arc is equals to this arc. Conversely, if length of arcs are equal, then corresponding chords are equal. Clear? Next one, congruent arcs or equal arcs of a circle subtends equal angle at the center. So see, these two arcs are congruent, so it subtends equal angle at the center also, right? So ये हम लोग आराम से प्रूफ कर सकते हैं. कैसे? According to this statement, corresponding chords are equal. If chords are equal, chords subtends equal angle at the center. We have seen at the starting, I think 10.1 theorem, right? 10.1 theorem. Okay, now we are moving towards one of the most important theorem of this chapter, that is theorem 10.8. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Okay, so these are the three situations. First is see, this angle is the angle subtended by the arc at the center. So in all the three cases, this is minor arc, this is semicircular arc, and this is major arc. Okay, so अगर ये AB arc हम लोग ले रहे हैं, so what is the remaining part of the circle? This one. Okay, उसको मैं एक काम करता हूँ, ग्रीन से ड्रॉ करके दिखाता हूँ. दिस इज द रिमेनिंग पार्ट. अब रिमेनिंग पार्ट में कहीं पर भी एंगल वो बनाएगा, वेयर एवर इट विल मेक, this angle is double of this angle, right? Statement is clear, and we have to take up all the three cases. So first, a circle with center O and radius R in which arc AB subtends angle AOB at the center and angle ACB at any point C on the remaining part of the circle. And what we have to prove? Angle AOB is 2 times of angle ACB when AB is minor arc or semicircular arc. And in the third case, reflex angle. This is reflex angle. Why? Because it is more than 180 but less than 360. So this angle is equals to 2 times of angle ACB, where AB is a major arc. So यहाँ पे हम लोग कंस्ट्रक्शन जो है वो कॉमन करेंगे. We will join CO and we will extend up to D. Right? C देखो यहाँ तक D तक extend कर दिए और इसको भी ज्वाइन करके एक्सटेंड कर दिए. सो विल गेट दिस फिगर. एनी डाउट टिल कंस्ट्रक्शन?
No, sir.
Okay, now proof part. So we have three cases. Case number 1 when AB is minor arc, and case number 2 when AB is a semicircular arc, case number 3 when AB is a major arc, right? So we will start with the first one. When one angle of triangle is produced, then an exterior angle so formed is equal to the sum of the interior opposite angles. You can write simply by exterior angle property of triangle. So what you will get, see, this angle is equals to sum of these two angles. Okay, angle AOD is equals to angle OAC plus angle OCA, right? And angle BOD, the other one, angle BOD is equals to angle OBC plus angle OCB. This two is clear?
Yes, sir.
Right.
Sir.
Now, but angle OAC is equals to angle OCA. Why? Because OC is equals to OA, radii of the circle, and we know that angle opposite to the equal sides are also equal, right? Similarly, these two angles are also equal, this one and this one. Now we are going to see एंगल AOD जो है एंगल OAC प्लस एंगल OCA है और ये दोनों इक्वल है, राइट? सो वी कैन राइट दिस एंगल as angle OCA, so it will become 2 times. Similarly, angle BOD जो है angle OBC plus angle OCB है, and what we will do, we will replace angle OBC by angle OCB, so वो भी 2 times हो जाएगा. So we will get angle AOD is equals to 2 times angle OCA, angle BOD is equals to 2 times angle OCB. Whether this is clear?
Yes, sir.
Okay. Now in figure 1 and 2, if we add these two, what we will get? Adding angle AOD and angle BOD, what we will get if we add these two angles? Angle AOB, right? And if we takes 2 common from these two, and if we add these two angle, this one and this one, we'll get angle ACB. So ये proof हो गया first और second figure के लिए. Now for third figure also we'll do the same thing. We will add these two angles. But if you add these two angles in this, we can't write angle AOB because this is a reflex angle. So we'll write reflex angle AOB is equals to 2 times of this angle and the sum of these two angles is angle ACB. So this is the proof of this theorem. Any doubt?
No, sir.
Yes, sir.
Okay, now the extension of that one is the angles in the same segment of a circle are equal. So first see this figure, same segment मतलब ध्यान से देखो, अगर मैं एक chord बना रहा हूं यहाँ पे, तो chord divides two segments, circle into two segments. So if I am talking about this arc, so this is the same segment. यहाँ पे कोई भी angles अगर ये बनाएगा, all will be equal. All angles are equal. This angle, any angles you will make, all are equal. So we have to prove that these two angles are equal. Okay, right? So we'll do one construction. We'll join OA and OB. Right? OA को join कर लिए, OB को join कर रहे हैं. Now, just now we have studied that the angle subtended by an arc at center, this one, is double by it at any point on the remaining part of the circle. So that means angle AOB is 2 times angle ACD. Right? Similarly, angle AOB is 2 times of angle ADB. Whether this is clear?
Yes, sir.
So therefore these two are equal. And if we cancel these two, we'll get angle ACB is equals to angle ADB. Any doubt?
No, sir.
Okay. Now let us move towards cyclic quadrilaterals. A quadrilateral whose all the vertices lie on the circle are called cyclic quadrilaterals. Quadrilateral के चारों vertices अगर circle में होंगे तो वो quadrilateral को हम लोग cyclic quadrilateral बोलते हैं. ठीक है? If all the four vertices of it lie on a circle. So here in this figure, A, B, C, D is a cyclic quadrilateral because vertices A, B, C and D lie on the circle. And with respect to cyclic quadrilateral, we have one very important theorem that sum of its opposite angles, these two angles, or these two angles, A or C, is equal to 180 degree, right? So this theorem is also important. The sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. So if you remember, I explained the two methods to prove this theorem. Again, I will going to repeat the two methods. So let us see the first one. We will join. First, let ABCD is a cyclic quadrilateral given. What we have to prove that angle A plus angle C is equals to 180, angle B plus angle D is equals to 180. दोनों proof करना है. So we'll do one construction. We'll join OB and OD, right? OB or OD, right? उसके बाद, now we know that the angle subtended by an arc at center is double the angle subtended by it at any point on the remaining part of the circle. So this angle, reflex angle, this one is equals to 2 times of angle BAD. Similarly, this angle is equals to 2 times of this angle. Okay, angle BAD is half of reflex angle of B. एक मिनट, मैं कलर चेंज कर देता हूँ. ये जो रेड कलर से जो बना रहा हूँ ये रिफ्लेक्स एंगल है. दिस विल बी 2 टाइम्स ऑफ दिस एंगल. ओके, एंड दिस एंगल is 2 times of this angle, right? So ये जो एंगल होगा, एंगल BAD is half of this angle, reflex angle, and this angle BCD will be half of BOD. Clear? And what is the sum of these angles? What is the sum of these two angles?
180.
360 degree complete angle. Okay, so if we add these two, what we will get? Half of reflex angle. We'll take half common from these two. Okay, so half common lenge and the sum of these two angle is 360 degree because that will make complete angle, and half of 360 is 180 degree, and BAD angle actual में angle A है और एंगल BCD एक्चुअल में एंगल C है. So we have proved angle A plus angle C is equals to 180 degree. Now second part we have to prove angle B plus angle D is equals to 180 degree. Now we know that the sum of all the interior angles of a quadrilateral is equals to 360 degree. Right? इसमें एंगल A प्लस एंगल C ऑलरेडी हम लोग प्रूफ किए 180 डिग्री. सो उसको हम लोग रिप्लेस कर देंगे. Now shift 180 to this side. So it will become 360 minus 180, that is equals to 180. So this is the proof of this theorem, and this is one method. Let us see the alternate method. Now maybe ये वाला method easy लगे. So यहाँ पे क्या करेंगे हम लोग, diagonals को join करेंगे. Join AC and BD. Right? And we'll mark this angle as 1, this angle as 2, this angle as 3, and this angle as 4. Right? See, हम लोग एंगल 2 इज इक्वल्स टू एंगल 1 पहले लिख रहे हैं. एंगल 2 इज इक्वल्स टू एंगल 1. व्हाई?
Angles in the same segment.
Right, angles in the same segment. Okay, and angle 3 is equals to angle 4.
Angles in the same segment.
Right, same angles in the same segment. Right. Now adding these two, we'll get angle 2 plus 3 is equals to angle 1 plus 4. Angle 2 plus 3 is equals to angle 1 plus 4. Okay. Now what is the sum of these three angles? Angle 2, angle 3 and this angle.
180.
Why 180 degree?
Angle sum property of triangle.
Very good. Angle sum property of triangle. ओके, अब एंगल 2 प्लस एंगल 3 को मैं रिप्लेस कर रहा हूँ BAD, एंगल BAD. ठीक है, क्योंकि ये एंगल 1 प्लस एंगल 4 इज इक्वल्स टू एंगल 2 प्लस एंगल 3 है. एंगल 1 प्लस एंगल 4 को मैं एंगल BAD से रिप्लेस कर रहा हूँ. नाउ विल टेक एडिंग एंगल BCD टू बोथ साइड्स here. So angle BAD plus angle BCD is equals to angle 2 plus angle 3 plus angle BCD, and this is equals to 180 degree. Just now you told angle sum property of triangle, right? So the sum of these two angles is equals to 180 degree. Now इसके बाद का स्टेप बिल्कुल सिमिलर है. Angle A plus angle B plus angle C plus angle D is equals to 360 degree. Now we'll replace angle A and angle C both by 180 degree, right? And we'll shift this side. So angle B plus angle D is also equals to 180 degree. Which method is easy, this one or that one?
This one, sir.
Okay, fine. Any method you can use, right? Now the next section is assignment questions. Only 2 questions are there, and here in the first question you have to find angle AOC, right? This is the first one, first figure. And in the second one you have to find angle BAC, this one. And second question you have to find angle OCA and OAC, right? So these assignments you have to complete and you have to send through Google Classroom. Okay, so that's all for today's session. Thank you very much.